How's the sound, if anybody's in there yet? Let me pull up the chat. today. Probably going to try something different today, maybe designing a part for holding something just so you can see how to do it. It's going to be a little different. Let me check on the clock here. So I'm going to bring up OpenSCAD. So today I think I'm going to do something different, and that's going to be show you how to design a part. Because a lot of people like to print, but sometimes they want to make their own stuff. So what I'm going to do is I'm actually going to go find a motherboard in the browser. So let me pull up the SKR. So if you're in the web page and you type Big Tree Tech or BTT, GitHub, SKR 1.3 or 4. Let's do 4. We can find out what the dimensions of that part are. So we can go over to hardware, and let's see if we can find the schematic. Yep, that's the different run. See if I can find it here. Well, we're probably gonna have to look in the manual here. So inside the manual, there's dimensions of your board. So let's see if we can design the actual dimensions. This isn't gonna work out perfect, but here are the actual dimensions. So if we go over to OpenSCAD, we can actually put those dimensions in. So we'll say the length is, we'll do 109.67. And then end it with the semicolon. And then we'll do the width, if I can spell today, of 84.3. And then end that with the semicolon. And we'll do the height. And we'll say that's 2 millimeters. To draw this, all we have to say now is it's a cube. We have parens, and we have open and closed square brackets, and it's going to be X, Y, and Z are the normal dimensions. But we're going to say the width is going to be width. The length is going to be length. And then the height's going to be height. We're going to end that with the semicolon. If we render it with this little Z here, we can actually see it. Now, if we want to put holes in this or cut out space where we don't want to print, we can do difference. And anything after the first element, being cube, will be subtracted. So to say in space where we want to do that, we're going to say translate, and this will say where it is spatially. And it's open and close paren, open and close bracket, then it's X, Y, and Z. So I'm putting zeros for now, and I'll show you why. So I'm going to indent both of these because we know they're inside the difference function. And I'm going to do a cylinder initially. And I'm going to say the diameter equals, we'll do 10, just so you can see what's going on. Then we'll do comma. The height equals height. And then the amount of roundness, in this case, we're going to say $FN equals, and if we do 6, this will give us a hexa shape. So I'm gonna render it and see what it looks like. And it doesn't look like I did very good here. So it's saying something about it being ignored. So now I had to figure out why. So I can go over here and put an exclamation point to see what's going on. And it's still not showing up. So I know the error is here. So the question is, what am I doing syntactically incorrect? So what I'm going to do is copy a line. I'm going to do translate. And then I'm going to do this over again because maybe I typed something funny. And I'm just going to say cylinder. And I'm going to say D equals 10, comma, H equals 2, comma, $ FN equals, and I'll say 30. And then I'll end this all with the semicolon. And we'll see what we get with an exclamation point. So apparently I've got some kind of issue where it won't render that. So there's some kind of error that I'm creating. Let me see if it's a missing semicolon someplace. Oh, here it is. Difference. So I can take out this line. I know that's not the issue now. Put a semicolon here for a second. And we know that we're getting the right shape. Now we can subtract it from that shape. As you can see, it's right there. So now I want to move this over. So I'm going to make this bigger. I'm going to make this 100, just so it's exaggerated. And you can see that it's cutting out. Now we're going to move it. So we're going to say that it's half the width. We'll copy the width, paste it here, and we'll say divide by 2. We'll do the same thing for length, and divide by 2. And we'll still start at 0, which is the surface of the plane. See what it looks like. So now it's really big. So now we can take this down in size to like 50. And now we have a hex. So we can make this more round now by changing this to 30. And now we've got a circle. So we've cut out some material. Let me check on the chat, see if you have any questions while I'm doing this. Yeah, sorry, it took me a second to read the chat. How's it going, Moxie? This isn't a replay. I'm actually doing it live. I just thought I'd do something a little different today, unless there's something else you want to see. Essentially, what I'm doing is just showing you how to make your own parts. So, is this something that interests you, or do you want me to show you something different? Yeah, it's OpenSCAD. So basically, I design almost all my parts in OpenSCAD, as funny as that seems. I don't know if it's a bold move doing this live, but I'm trying to show you how to make part holders. So I figured the simplest thing is to show you how to make something for a motherboard so that you can keep it on a non-conductive surface. So I was going to show you this in pieces as I went along. You can do 2D extrudes too with primitives. Right now I'm just using objects. So I'm going to put posts on this, but I'm going to make a function to do that. So I'm going to say module, and I'm going to call it post. I'm going to give it no parameters for the moment. And then I'll say open and close bracket. And all I'm going to do inside here is I'm going to say difference. And I'm going to say the cylinder and I'm going to say that it's 6 millimeters wide for the moment. And the height we'll say is 3. And then how round it is, we'll do $FN equals 30 semicolon. And then we're going to take out of that the center. So I'm going to copy and I'm going to paste it again. And this will subtract from it. And seeing how we're only doing 2 subtractions, I'm not going to put a bracket around it. But I'm going to make it 3. So let me take out that and that. Put a semicolon here and a semicolon here. To run it, we have to grab the function name, put it up here, put a semicolon after it, and then an exclamation point so we can see just that. So there is the cylinder. It looks like there's no hole in it. So let's try putting parens around this, or brackets. And seeing if we get anything. There we go. So you do need the brackets. So this would be something to hold the actual post that you bolt through. So what we can do now is we can actually call this, I don't know if this will work, but union. And this means combined stuff with it. And let me indent this. And we're going to do the post at the end of this. I don't know how well this is going to work, but we'll find out. Post. And in order to create the post, we're going to say translate. And we're going to say where it is spatially. So 0, 0, 0. We know it's going to be 2 millimeters high. And then we're going to move it over, we'll say 3. And then 4. We'll see if this works after I remove the post up here. So it created a post that sits on top. Now we just need to figure out where to put it spatially. So if we go back to the browser, we can see where the posts are. So inside the browser, it says 109.67 minus 101.85 for where the holes are. So we know that we have to do some subtraction. So I'm going to make a variable in here. Where I say hole position equals length minus, we'll say 101.85. And there's 2 holes. So I think it's division by 2 if I remember correctly. And then a semicolon to end it. And so we'll change that variable, being hole position, to where we're going to position this first hole. And that's going to be actually right here. But we'll worry about that in a second. So let me just fix what I did here. And let's see where that hole goes. So it doesn't look like it moved, but let's do the math on this real quick. So 109.67 minus 101.85. That's going to give us, what is it, 2, and then it's going to give us 8, and then it's going to give us 7. So we know that the hole is probably 3.5 millimeters from there. So to troubleshoot to see where that is spatially, we can cheat by doing this. Delete this for a second. We'll say echo, and then we'll say hole position. And this will tell us where it is. We'll end that with the semicolon, and then we'll see what comes up down below. So there's an echo hopefully someplace here. It didn't work right. Now I gotta think about it for a second. So I'm gonna cheat and do echo, and I'm gonna say hello world, and see if this works. So apparently I got the nomenclature wrong, maybe. Or it printed just before I started. Nope, didn't print. So apparently the echo's not working for me at the moment. It might be that it's in brackets. Doubtful, but see what happens. That is incorrect. So the next thing we can do, if this doesn't work, is we can say translate, and we'll do something spatially. So I'm going to say this line again. This is another way to figure out where it is. The hole position, I'm going to copy this line. I'm then going to say that it's 5 above. We'll do a cylinder that's 3. So I'll copy this. This is just so I can see if something's spatially centered. And we'll call that 2. We'll see what it looks like. So we are where we think we are. I just need to know that one value. So I can actually change this and guesstimate that it's around 3 and see what happens. So it's 3.5 probably. Up, 3.75 maybe? Yeah. So we know it's 3.75, and we know this one's probably going to be 3.75 as well. These are just guesstimates. Normally I use echo. So I'm going to do the same down here. And that's where the hole theoretically will be. Now to do this for the next couple of holes, we're going to do the same thing, but we're going to cheat. Because we're doing width here, we're going to say width minus. And then we're going to do the same thing for the actual length, which is going to be length minus 375. And let's see what happens. So it's in the other corner. So now we could probably cheat, copy this line, paste it here, and instead of width, we'll just do 375. That gives you the other hole. And then the very final one would be the length. Copy it, paste, and then back this out and put this one as width minus. And then we should have all 4 post holes. So this will allow you to actually put your board on there. There are other things you can design into it, ways to attach it. You can make it a container. So let me show you how to make it a container real quick, hopefully. I'm gonna get rid of this for the moment. And I believe we'll make a cube out of it this time. So let me take this and clean it up here. And we're gonna make the height bigger. So let me get rid of all this. So now the height will make 10 or 15. Let's try 10 for now. So now we have a bigger container. Let me take out the subtraction there. Now we want to take out something inside the container. So we can copy this. We can do a translate. We'll open and close bracket it. We'll say it's 2 above the center. And then we'll reduce these by 5. Technically you'd increase, but I just want you to see the actual container. So it's 5 smaller, and so we'll go 2.5 millimeters on either side for an offset and see what we get. So there's a container. So normally it would increase the size of these to account for the outer edge, but I just wanted to show you how to make the container. And then of course you can make a lid by doing a subtraction from this. So if we were to say module container, and then put this in brackets, we can make the container real quick. So inside here, we just have this container. So watch what happens when you do this. So we're gonna copy this, we're gonna verify that it actually shows up, which it will. Now we can go over and we can do difference, open and close paren, container is going to be second, so we're going to do a lid. So the lid we'll just say is a cube, and it actually copies this. And we'll do +5 just to make this easy. And we'll position it in space. So here we go. I'll check on the chat in just a second. We're going to do 2.5. Well, no, it's going to start at 0. So we're going to subtract the container from this, hopefully. I don't know how well this is going to work just out of the gate. But let's raise this up about 5. And you can see that it's cutting into it. So we just have to figure out how to center that. We're going to move it over 2.5 and see what we get. So apparently I'm moving the wrong direction. We're not moving enough. Let's try exaggerating it. So what I'm actually doing is moving the actual lid, so that's not good. So it's going to be minus 2.5. So there's the cutout. And then we're probably going to do minus 2.5 here. And that's where the actual lid is cut out. So now we need to make this a little bit smaller. So we'll say minus 5. Not working. So apparently it's overlaying one with the other. Whereas I don't want the container to show up. But it's showing the outline of the actual box being cut. So this part here we could cut out with another translate. Put it here, but I'm going on way too much here. This is actually the piece that's not cut. It's actually the outer lid. So we'd have to make this a solid. That's what's actually cutting it. But we can figure that out in a second. Let me see what chat's doing. I know this is kind of dry. Yeah, I'm doing 3D primitives right away. This is how I design a lot of parts. Usually they look better when I'm doing it by myself. When I'm doing it publicly, obviously it looks rich with errors. But let me pull up one that I actually am working on. This is the holder for the BL Touch. See if you can see that. Hang on, let me close the other one and make it visible. There we go. So this is a little bit more complex. This takes a little bit longer to render. Got a lot more in it. Not much though. But this is what it looks like when it renders. Let me just move this over. This is how I designed that one printer that everyone keeps asking me about, being the multi-use Mendel. I actually designed it all on this. I'm probably going to redesign that one of these days. I just got to find the old files. Because it's been like 3 years or 4 years. Of course, the render now is taking forever, so I'll look at the chat. So is there any questions you have about actual 3D printers today that I might be able to answer? I've got the MOSFET for a motor, but I still have to look up how to do it. So I'm holding off on that. I also found some old 3D printer motherboards like the SKR version 1.1 if anybody wants to see that. I know it's out of date, no one uses it anymore, but this is about to pop for the render. Of course, just before the end it slows down. But I'm also grinding up a lot of the bandwidth on the computer today, so it's probably going to take longer than normal. So here's the part. Basically got a fan holder here. The hole isn't really necessary, I just thought I'd put it in there. This is where the BL Touch will go. And then this is where it's going to mount on the actual Creality or Ender. So it's not really a complex part, it's just figuring out where things are in space. And then lining them up and possibly doing a lot of prints. In this case, I think there's probably upwards of 20 prints that I've done to get this into the shape that it is, but I also used a lot of different tricks to save on it. Such as printing a very thin layer, matching up the holes. Then increasing the height a little and printing more thin layers. And that's basically how I developed the part. This I need to clean up. That's where the BL Touch will go. But I'm trying to figure out wire management for this right now. And I put countersinks up here so you can just screw it into a 3mm bolt. You just bolt right through it. And then it also can countersink into this by threading it when you're bolting it. The same goes true for everything else here. Everything is designed to hold the part in a certain way. This is designed for the dual color extruder or hot end. It just slides into here after it's been bolted on. So, anybody have any questions on printers? I gotta bring up the lighting and the actual cameras. Okay, all the lights are on. Let me see if the camera's working. Okay, the camera's working. So, here's a part that I actually found for one of the MOSFETs. This is actually for a motor. I still haven't had a chance to go into it very deeply. Obviously, it's still in its packaging. But it's a way to run power to your motor. So I'll pull it out so you can see what it looks like. So there's the back end of it. It's got some interesting writing on it. It says, let me pull out a little pointer here. It says 5 volts. Then it says CLK, which I'm assuming is clock. Then it says CW, which I'm not sure of, and then enable. So EN. So I'm assuming that's enable. Then over here it's got the pins that possibly match up to right here for your pins. So it's got an A+, A-, B+, B-. And then it looks like it takes upwards of 32 volts. So, I haven't actually messed with this yet. There's a little key probably on here to say what to do. And then there's a heat sink. And then you have your inputs. So it looks like you do an input from your from here to here, but don't quote me on that yet. And then there's dip switches to turn on and off things. And then you have your output power, I believe, right there. Or your input power, excuse me. So it's a really simple device. I just have no clue how to use it yet because I have to read up on it. And to show you this on the table by itself might not be super wise. So I might have to build a container like I was just showing you. That's one of the parts we can eventually talk about. The BL Touch is almost done. I just have to mount that in a printer for you. But I got a whole bunch of new stuff. Currently a new LED came out from Big Tree Tech. It's called the, well, I like how they put the writing on the box today. Should be something. Oh, it's the TFT 35MZ version 3.0. I'm wondering if this is gonna work with here's the actual container. It's not real easy to see what's in it, so I gotta open it. So it comes obviously with some cabling, a knob, TFT cabling, and then the board. And I think with this board, it's very similar to the E3, except they don't lock on the knob. So if I flip this over, we can check out the functionality of it. Looks like it takes USB. Also says on the board, I have to read it close. It's got a programming port, which is SWD, I believe. Then it has your regular UART, which would connect to your UART over here. Someplace over here, right here. And then it looks like more UARTs. There's a UART 4. And then filament detect, so one detector, I think. And then not sure what the 3.3 volts with the ground and the pin over here are, but that's probably some kind of end stop, possibly a switch as well for filament runout. Then we've got 3 ports for, it looks like, your monitor, and then possibly a port for Wi-Fi. I gotta look all this up because this is totally new to me. And then it's got external power for 5 volts and ground is my assumption. And then of course your reset button. But we can look up to see what it looks like. I've never actually used this board, as you can tell. So let me go over to the browser and see what we've got. Gotta look up the name here. So if we go to the browser, we're actually on the website for them already. So I'm just gonna go back, go to Big Tree Tech, and let's see if we have anything on the TFT. So there's the Big Tree Tech TFT E3, and this one is the MZ3. So I don't know if they're going to have documentation easily found here. So it looks like they do. Looks like this is somewhat recent. There's a PDF. It says something about it being dual mode. Essentially, it's the same as every other TFT that's 3.5. Looks like it's got filament detect, PS on, so power supply on is what I'm guessing that is. And then it's got 3 connections for your LCD. Technically, most people use 1 or 2. It might be that you can use those for other pins. And that's it. So not a lot of information. Maybe there's firmware here. Oh, it's just more PDFs. And looks like Chinese. I don't know what they're saying in these, so let's go inside them and see. Oh, they're saying what the actual board layout is. This is probably easier to read. Looks like there's 3 UARTs on here. So here, here, and here. And UART's just a wiring scheme that you can run with a certain chip to communicate with certain things. Just like SPI. SPI, they usually use chip select, which is a numbering system like mailboxes for different components. In this case, pins. But there's not very much more on this. I don't even know if there's a firmware for this yet, because it looks like they didn't say anything about a firmware. But let's try and hook it up and see if it works. So I'm gonna first clean up my Marlin while I'm doing this, and also my desk, because I just laid out a bunch of things across it. So let me unzip this file real quick and we'll try this, see if it actually works. So I'm going to make the assumption on this board. I'll show you what I'm going to do. On this board, we know that there's a TFT connection. So like always, we're going to take the connection. We're going to find out on the board where we need to connect it. is probably right here. Yeah, it says RS232 and it's UART2. Then we need to connect it to this over here. And I got to find the reset pin. I believe it's on the right or left side, but you can technically power this, not damage it. But if we see smoke, then I made a mistake. So I'm going to guess one way, and then I'm going to flip it 180 degrees. So I'm going to unplug this for a second. I'm going to change this to 5 volts of power. We're not going to use the actual plugged in power. Plug this in. See if I did the pin right. Look like it. There we go. So it's not plugged in correctly. So I'm going to unplug it, flip it. See if it works now. No, it really doesn't work. That's awesome. So it might be that it needs external power. Let me unplug that again. But let's look up what the actual pins are, because maybe I'm doing it wrong in the first place. So if we go back over to the browser, and inside the browser, we need to go to the SKR. Oops. Then 1.4, then hardware, and then pins. So 5 volts. Okay, resets on the left hand side right here. So I plug that in. I plug this in. In theory, it should power, unless I'm plugged into the wrong place on the back of the board. So it's not working. So I'm going to flip it back over and make sure that I'm connected to the right thing here. So it doesn't want to power up. So we're only running 5 volts. We shouldn't have done any damage to it. But it's giving me the willies for a board right now. This might be designed for a different actual board configuration. Or I just got a dud and I keep showing you it. That's awesome. So I'm going to actually run some juice through it then. Maybe it's not powering up. If you see smoke, then I really messed up. Yeah, it looks dead as a doornail. So maybe this is not a good idea. Or I've got to read up on this board more. I might be able to power it over here. So that's for 5 volts. So I have to actually set up something to do that. So we might be able to run it off the pins on this board. Let me see what we got for 5 volts. So we could probably run it off the end stop and see if we can power it. So I've got to find a jumper to do this. Of course, I made it slightly messy over here. Let's try these jumpers. Everything's powered down. So I'm going to use red and black. And I'll show you what I'm going to do. So on here, I'm going to connect the voltage. I'm going to connect the ground. Then I'm going to go over to this board, and I'm going to connect the voltage and the ground. So voltage right here, then ground. In theory, this should power up if it's okay. If it's not, it's broken. So I'm going to move this jumper over for voltage off the USB. It does work. So the question is, why is it not working with the cabling that they gave with it? It might be that they're not powering it through this cable. So we can check that now. So I'm going to disconnect this and this, and I'm going to see if there's any power going through this cable. It's a lot of weird troubleshooting, I know. Normally I don't do this on camera. I usually do this before I show you it, but I figured I'd let you see my confusion. So we don't know exactly where everything runs on here, but we can examine what these say, being the stripes of the wires. Then we can go over to the browser and find out what's going on. So if you go in here, you can actually troubleshoot. So there's RX, TX ground, and then NP power. I'm guessing NP power is voltage. So I'm going to take out a multimeter and measure this. Right now I'm running at 5 volts. So we can test this out by putting the multimeter down to millivolts. And do this very carefully. So we're only measuring the 5-volt chip. So we know that this is ground. Hang on, I gotta unscramble these wires a little. So we're gonna take the probe and put this here for ground. Then we know this is voltage. And it doesn't say anything. So I'm doing something incorrectly. Try this. So it's 5 volts. Now we can go over to here, and we think this one's 5 volts. And it's 5 volts. We know that's working. We want to test ground. It's the second pin over. It comes up at essentially 0. We know that works. Now we can check the actual cabling. So I'm going to connect this here. Then I got to trace out the wiring. So I'm going to power it back up. And I got to figure out what that is. So it looks like a long stripe. So if we look over on this side, we see a long stripe right here. So we're going to measure right there. So that should be 5 volts when it comes up. So I'm going to stick the probe over here. Stick the other probe, I think right here. So I'm not really seeing. My view might be bad. Oh, it's 5 volts. But it's kind of jumping around on me because maybe the way I'm holding it. Try another one. 0. Get voltage right here. Let me try sticking it inside it. So it is 5 volts. Sorry, it just takes a while for me to get this into the right place. I know you probably can't see the multimeter that well, but I don't have a lot of space to show you. So it looks like the cable's working. So the only question is, why are we not getting 5 volts to the actual board? And so that question is probably relevant to the tracings. So the next thing we can do is this. This will help us, hopefully. We're going to connect this up and see if we get voltage. So I'm going to connect it right here. And then I'm going to look on here and see if I can find voltage. And we'll probably have to look around the board a little. So it says that 5 volts is on the right side. And the right side goes to, I believe, this one, which is TX. So it might be a cabling issue. But let's cheat and see what the multimeter says. So here's the multimeter. Sorry, it's kind of difficult to fit everything in here. So I'm going to click here, and I'm going to measure this pin. Not that one. I'm going to measure this pin. Not that one. Looks like that's 5 volts. That's half a volt. So the voltage is coming in right here. Let's take this out of the way and look at the board again and see what the actual tracings say. So if I turn this up and I look at it, looks like we're looking at the TX, and 5 volts is on the very right hand side. So if we trace out the cables here, we see that there's a dash all the way up that goes into here. But over here, we see a dash on the far left-hand side for TX. So there might be something going on with our cable. So let's try a different cable. So this is the cable that I have from another one. I'm going to plug it in here. I'm going to do the exact same thing for here. And then plug it in here. And now it powers up. So apparently they sent me a bad cable. So if you ever have a situation like this, that's probably a way to troubleshoot it. Let's see if we can actually make it work now. So I need to go into actual VS Code. I know that was incredibly... Oh crap. Sorry, haven't been showing yet. Let me go back over to the workbench. Apparently I did a lot of troubleshooting while I was not there. So I'll show you what I did. They gave me a cable with the actual board for this. And they did something funky with the actual wiring of this, where they don't match on the other end. So I'm actually holding the wrong cable here. Let me take a look around. So I thought this cable was defective, so I'm going to disconnect it and reconnect it so you can see what I was talking about. So I took this cable, connected it like so, and then connected it to the monitor or the TFT. It didn't power up, and apparently I'm holding the wrong cable now. I have like 3 of these on my desk. Or it's working now all of a sudden. Hang on, let me make sure I didn't toss the cable across the room. Well, it might be buried across here, but essentially it's not working, which apparently my troubleshooting skills are either really good or really boring. Or really bad. But when I plugged it in, I didn't get this to light up. So I took out a multimeter instead of measuring all the leads and then tracing these cables. And at the time, I thought my cabling for voltage over here was incorrect. But now that I look at this cable, it's correct. Well, it's not correct. But for some reason, now it's powering. Maybe it was a loose connection or something, which is highly probable. But essentially what I was doing was measuring with the multimeter each one of these pins and tracing out if voltage was coming across. And at the time they weren't. And after I plugged it in a second time with that cable, it started working. So apparently that was kind of useless. So let's see if we can actually load firmware. Hopefully I can bring you to the right place that I'm going to be in. When I do these tutorials, sometimes I obviously don't try them out ahead of time. Part of the reason is because I want you to see my my thought process. So I'm going to open up a folder here. I'm going to go to downloads, grab my Marlin, 2 folders deep. And I can't remember if this is 3 for this board for the second serial, but we'll just do a basic setup for now, because I might have to guess. So we'll go to boards, we'll search on SKR1, and it's a turbo in this case. Is down here. It's the 169 chipset, or 1769, pardon me. So we'll go into here, we'll search on motherboard. And we'll paste it over here. Then we'll go up and we'll change this to -1. And then the second serial port we have to do, so we need to remove the comment to enable it. It can't be -1, so we'll start with 1. I think it might be 3, but it could be 4. I forgot what these are. And so we'll go to platformio.ini and we'll change this to LPC 1769. And then we'll load it. This will take a couple seconds. It's failing on me, probably because of last night. So something about the LPC 1768. So I'm going to clear that out because that sounds like it was last night's. Rebuild. And now it's building. So every time you do a build, sometimes it's stored up in here and some of the information isn't cleared out. So when you do a new build, you have to hit this button right here to clean your build. So we all know about the process that I do when I check my desktop. It loaded just now. So I'm going to disconnect that. I'm going to go over the workbench. Hopefully the camera won't go out because it's almost 30 minutes. Plug it back in. And right now it says no printer attached still. So what we need to do to configure this possibly is go to menu. Whoop. Back. Kind of cool functionality. Settings. Our speed is probably that right there. Hit enter. So there's no change. So I probably have the wrong port number for the serial port for the second one. We have to go back to VS Code to figure this out. So inside VS Code, go to configuration.h. We'll try 3 this time. We may have to go through all these numbers. I know that sounds crazy, but we'll... Whoop! Did I forget to power cycle? No, I didn't. Sorry. So now it's loading or building. And then we'll go over and we'll check firmware on the drive as soon as this finishes, which is just now. So over here, we'll go to the desktop. You can see it just loaded again. We'll go back to the workbench. I'll disconnect the power. I'll reconnect the power. And so far, nothing. So we're gonna have to do this a couple of times probably. It may not work, which is okay. But let's check inside the menu. Settings. Whoops. Speed. Bring the camera back on. So the speed's right. So let's go back to VS Code. So inside VS Code we picked 3. Let's try 2 next. Just keep in mind, I don't know if this is going to work because it's just out of the box and I haven't read up on it. And now it's failing. Do a clean. And try that again. And it's still failing. So let's look at what the actual issue is. So it's saying that we can't use that serial port because it's conflicting with something else. So we haven't tried 1 yet. Let's try, well, we did try 1 yet, sorry. Let's try 0. So some of these pins might be reserved or serial ports. Serial ports composed of multiple pins, being TX and RX usually, and then ground in voltage, I think. So that loaded. I'll show you what I'm talking about. And let's go back to the bench and power cycle again. And that worked. So apparently it's 0. That's news to me. That's normally not that number. But we just figured out how to set it up. Now we can actually try and move a stepper if you want. So let's give that a try. So if we go over to VS Code, we're going to set up this stepper kind of quick. So I'm going to search on A4988. We all know what the stepper is because apparently I've covered it ad infinitum. So I'm going to copy this, paste it here. So we've got that set. Now we need to go to advanced configuration. Oh, we got to invert. Sorry, I forgot about that. So down here, this needs to be true. Now we can go over to the advanced config. We're just going to search on sensorless homing. Here we go. We're going to move the comment, change this to 125. And then we're going to hit build and hopefully it won't explode. We're going to be running off direct power in a second. So there's a new issue. Something about SPI. I don't think we set up SPI. But I could have fat fingered something. So I'm going to do another clean. Then try a build again. And apparently now it's working again. So sometimes when you make changes, you're going to have to do the clean. And then you'll do the upload build. So this reset's going to be different. I'll show you what I'm talking about. So we know on the desktop that it just finished. So we're going to go to the workbench and disconnect the main power. Disconnected right now. Going to move the jumper over to direct power, plug this back in, then plug this in. And then we'll see if we can actually move this. So printer's now online, so let's see if we can find move. I'm not sure if I'm going to find it right away. So it's probably in here. Probably says movement. Go to movement, and we'll move the x-axis. Got to find it. So it does work. So let's go back and see if we can do home. X. So it does work. So that's how we set up a touch panel and test it, which is, I know, super boring, but at least now we know. So let me check on the chat. I know I've kind of neglected you guys for a bit. Was that interesting or just the same as usual for me troubleshooting? Troubleshooting can be very boring, but you got to go in through your mind and say, what is going on? Where should there be voltage? Where should there not be voltage? I haven't had a chance to show you logic analyzers. It's kind of an advanced subject, but I'll show you what I'm talking about. I don't have one. It's someplace in a box, but let me bring you over to the camera. Well, you're probably already there. You can connect to each one of these pins with a particular device that connects via USB, and you can watch the pulses in microseconds moving up and down. It's a great way to troubleshoot if there's a combination of things going on. Unfortunately, I don't have one at my fingertips at the moment to show you. Usually they're big boxes that you use these on. But an O-scope would be another way to do it. Or even a multimeter if you can see it move quickly. But the O-scope has the ability to set triggers. You can actually see the rise and fall of voltage. I don't know if that was great. That was kind of me stumbling and bumbling. But that's basically what I do day in and out at my regular job, is measure pins. But the whole premise behind it is understanding what's occurring. And most of the time you don't understand it until you start probing at it in different ways. First step is usually a multimeter. Second step is check your cabling. Third step is start to dive into the more advanced things. Look for burn marks. But I'm pretty sure I haven't burned this board yet because no one's seen any smoke because I'm usually working with it live. But it is one of my favorite boards, as you already know. The SKR series is definitely the easiest board to work with for the SKR 1.4. The ones that are a little bit more difficult are the older ones. Let me show you an older version of this board. Let me just clean it up here. We can't run a lot of things on the other board without a lot of mods. So this particular board has, the tracings and the design so that you can actually work with it pretty quick. So get this out of the way. Alright, put something that looks like gum underneath. That's so the board doesn't slide around when I'm working with it. If anybody is an artist out there, you'll know what I'm using. But let me grab this board. It's the previous version. Okay, that's a different version of the board for MKS. I think I put it over here. Huh. Had it in my hand right before this. The S-Gen. I know I have this board on hand. I just had to find it. Put it up here. Oh, might be in a storage box again. Let me go see if I've got it. Essentially, it's the first version of the SKR, which most of you would be horrified if you saw it, because it's definitely difficult to work with. If it's in here. Oh wow. This is my old board collection, so you can understand why I get easily confused. It's one of about 4 boxes of boards. So I think this is it. That's the SKR 1.1. I originally was going to do a tutorial on this a long time ago, but never got around to it. I was doing actually 8-bit tutorials at the time. So let's try this out. Maybe it'll work. Right now, I think it's set to USB power, so let's see if it powers up. So it does power up. Let's see if we can actually load it. So let me see where we are on the screen here. I'm going to go over to VS Code. And some of this functionality we've got to disable, only because it's not set up for natively UART. So I need a second to change this around. Excuse me. So we're going to disable sensorless homing. We're going to disable the actual stepper. So we'll do A4988. And we'll change this back to an A4988. This is just so I can compile and not do any damage. It probably won't do any damage, but I'm trying to avoid it. And then we'll go back and we'll find motherboard, and I think all it is we change it to 1.1 or 1_1. So let's double check that before I do anything wrong. We go to core board. There's the actual board. Let's copy that and just put it in there. You're going to paste it right here. And this may not work, so let's find out how interesting this is. Let me comment out this. I don't have a TFT display. Well, actually I have a port for it, I think, but we'll have to look up the pinouts. So I'm going to comment it out for now, and then I'll do an upload. This might not work. Well, I got the chipset wrong too. So I have to go down here to platformio.ini. It's probably the 6.8. Let's go back and check to see if that was in the boards file. So it's LPC 1768, so we're good there. So I'm going to do a clean, and then I'm going to do the upload. And it may not work, but I do see the drive on my computer, so it may work. So if this works, then we'll try the LCD, and then maybe a stepper, but as you can tell, it's kind of a dry day on tutorials. For those that don't know, I do have a Discord, and you can put in requests for subjects that I can cover. If you can think of one and I have the equipment on hand and ready to go, I'll do that. But generally things like MOSFETs, I have to spend some time reading up on it because there's a lot of power running in a lot of different directions. So I'd like to know what I'm doing before I actually shock myself on camera. Otherwise, I'll start to look like the guy that does that. So let's see. I'm going to go over to the desktop for a second. Looks like the build loaded over there. So let's power cycle it and see what happens. Power it back up. And by the way, this is the OpenSCAD thing that I designed a long time ago. It's used to connect to a 2020 rail like this. So let's go over into Pronterface and see what's happening. So because we don't know what the USB is for the serial COM, we have to go over to the desktop for a second. And we have to check it. So if we go to COM ports, it's 19. So if we're over here, we have to change this to 19. And then we can connect. So it says printer is now online. Let's try M119. And it says they're all triggered. So we know that we're connected to this board. So I'm going to disconnect. Going to disconnect from the board. And let's see if we can hook up the display. I don't know how well this is going to go. So let's go over to the browser. And inside the browser, let's go and see if we can find the directions for this. So I'm guessing it's repositories and then version 1.1. And maybe not. So let's try SKR. Then version 1.1. Wow. There we go. So let's see if they actually have a manual. It looks like it's in Chinese. So maybe I can decipher what they're saying. It does have a TFT. So hopefully they'll show us a pinout of it. And that's not very helpful. Am I looking at the right board? Yes. Doesn't say what it is. You can sometimes see it on the silk screen of the board. And it may be there and I'm just not seeing it. But let's see if we can find a pinout diagram of this. So hardware. And then pinout. Inside here. It is absolutely a nightmare. They're not showing the pinout diagram. I'm guessing the square, I think, normally means ground. But it's hard to tell with their nomenclature because normally you would have a thing that says TFT down here. So this might be one of the reasons this board didn't take off. So let's try connecting it and seeing what happens. Because the worst we can do is set something on fire. We're going to do it the same as the other board. Let me show you what I'm doing, because obviously it makes no sense if I'm just saying it. So on the workbench, I'm assuming the same configuration as the SKR14. So I'm plugging it in there. And I'm plugging it in right here. And I'm applying power. And let's see if it powers up. Apparently not. Disconnect it. Rotate it 180 degrees. Plug it in again. Not working. I may have just rotated this 180 degrees and not figured it out. Now I'm going to plug in these four over here. This one over here. Technically, you won't damage your board, your display doing this, but probably best to read the pinout diagram. So maybe I guess I'll be showing you some troubleshooting. I'm going to disconnect this. I'm going to take out the multimeter. Hopefully I'll put it where you can see it this time. So here's the multimeter. Actually, I got to power cycle it again. And I'm just going to measure pins. So I'm going to go to a ground plane, and then I'm going to touch a pin. Normally you could pull these off the board. So that says 3 volts. Try over here. That says 4.81 volts. Nothing. 3 volts. 2 volts. 3 volts. So I'm assuming that's the 5-volt pin. Well, let's try this again. So 5-volt is going to be the dots, I think. I'm going to plug it in like so while it's still live. And we just figured it out. So this is probably reset over here. So reset, yep, it works. So to figure out the pins, you just have to measure them. I know there's a reflection on this when I'm using it. I can actually turn down that or off that light for the moment. But essentially what I did is I measured the pins on the board and realized which pin was actually hot with the most voltage being 4.28 volts or something. And that was the one that we needed to connect to. So without having the directions, you can actually decipher what they're talking about to a degree instead of using their browser. Or I'm sorry, instead of using the browser to figure it out, because we didn't know what these pins were. So this square pin is actually possibly true. Normally, if you look though, they make something funky here. It says their voltage pin is square. I think squares on most schematics are ground, but apparently I'm clueless because they're doing square here. Whoop, let me point to where you can see me pointing. So right here it says ground. Right here it says voltage. If you go over here, these equate to voltage instead of ground. And then over here, this was the reset button, so it might be ground. So now you can see why I'm confused, because over here, ground is actually the signal pin, and then voltage is actually the circle. So they're using these indiscriminately, which is kind of bad practice. And this isn't actually a ground. This is actually has power on it. So obviously, I'm not an electrical engineer, but I thought that was the process they use. But maybe you have a comment that I haven't seen yet. Yanasnaya, Niet. Sorry, someone's commenting in here, and I think they're trying to say it in Russian, or they're pointing to a Russian website. I don't know what that means, other than they want me to click on it, and I don't want to, and please don't click on it. I'll set up a filter to knock these out in the future. I really don't want to become famous, because as is, I like my privacy. So we'll let that go for now. Anywho, where's everybody from today? Trying to burn the clock a little. Maybe you'll have a question that I won't look so confused on. Or I won't demonstrate something I don't know how to do initially. So I know there's a couple people from, let's see, Moxie Boy, I don't know, are you from Israel, or Moxie's a Yiddish word for, well, I'm not going to say what the Yiddish word is. Derek, I'm guessing, is Europe someplace. Maybe we have some Portuguese in here today too? Or is everybody just being quiet and listening to me talk? Okay, well, if no one's got any questions today, you know about my Discord. Let me see if I can post it in the chat without it crashing. This will help you find me if you have questions or other people that have the actual answers. There are a lot of experienced people now in the chat. Here's my Discord chat. It's also in the description. I'll put it in the actual chat, and hopefully the chat won't crash on me. So here we go. That's the location of my Discord. If you need to ask questions, there's lots of people in there. It's in the general chat. I'll actually show you the Discord and what it looks like today. Let me just pull it up here. They've got 4 symbols that look just like it. Hang on, I gotta get it over there. So this is what the Discord will look like. The chat room is general open chat. I rarely do voice chat inside the chat room. And then there's a folder in here someplace for requests, or there used to be. Oh, YouTube requests. So if you have a request for something that you want to see, this is a good place to post it. Sometimes people ask questions in here. I'd rather just say, can you do this for me? I still haven't done thermocouplers. I have to order one. He's talking about a print head, I think, or a printer. But we already took care of that in the general chat, I think. But there's upwards of 100 and almost 170 people in here from time to time. Most of these people will be here to answer your questions. They come in and out when they're awake, or they're staying up late. But I'm gonna let y'all go. I've been talking for an hour and a half and didn't have a well planned out idea. Hopefully I'll have the BL Touch ready to go by next weekend to show you how to do that. I might have to pre-record part of it just to show you the process, because putting the printer on the table at the same time as working on the table, there's going to be like a 5-10 minute intermission where you're going to hear me knocking things over. So I might just pre-record the first section and then watch along with you and watch the chat. But thank you for taking the time to stop in today, and hopefully I'll have better subject matter where we can talk about the actual different types of Z-axis probing next week. So take care, be safe, and thanks for giving me an hour and a half of your time.